Hey, I want to share something that I just learned about T cells. T cells need interleukin 2 to be absorbed, but it needs the interleukin 2 receptor has to work in order for that to be possible. Basically, TREGs, overactive TREGs, which are recruited by cancer cells, they actually steal the IL-2 away from T cells, weakening the T cells so that the cancer cell escapes a T cell attack. So it's no wonder that cancer cells recruit TREGs so that the TREGs steal the IL-2. But basically, a fruit that can help out T cells is kiwis. So kiwis they increase IL-2 signaling and T cell responsiveness. So it's not just about IL-2 quantity. IL-2 being available is not going to be enough for T cells to be able to take it up. T cells also need CD25 to work out. TNF alpha also has to be reduced because TNF alpha destabilizes receptor clustering. So basically, the CD25 is the receptor. So basically, vitamin C in kiwis stabilizes the high affinity interleukin 2 receptor formation. And kiwis is one of the highest whole food vitamin C sources, and because it matters because it affects the activation of CD4 and CD8 T cells. So basically, vitamin C upregulates the CD25 expression, and it also enhances the STAT5 phosphorylation downstream of IL-2 binding. So basically, STAT5 is a marker that boosts immunity. Also, a STAT3 is a marker that lowers cancer cell resistance or makes them weaker. So basically, as a result of vitamin C, T cells bind to IL-2 more efficiently and signal longer per molecule. So basically, that's important because just because there's IL-2 available, it doesn't mean that the T cells are going to be able to absorb it and use it. Like the T cells need help. So in this case, with the kiwis and the vitamin C that is in kiwis. Basically, kiwi also lowers TNF alpha. Now, the reason that's important is that because excessive TNF alpha can downregulate CD25, and that pretty much means that the T cells are not going to be able to take the IL-2, or that's short for interleukin 2, to use it. TNF alpha also, this is also why it's important to have kiwis. That it's important for kiwis to lower TNF alpha is because if a TNF alpha is excessive, it actually pushes antigen-presenting cells toward a semi-mature state, which means that there's going to be a poor interleukin 12 support. So basically, antigen-presenting cells, they're supposed to activate T cells. But if TNF alpha is excessive or too high, then that's going to prevent the antigen-presenting cells from being able to activate T cells. So that's where kiwis come in to reduce TNF alpha. So basically what semi-maturation is in antigen-presenting cells, basically it occurs when they receive partial danger signals without full pathogen context. This is usually caused by lipopolysaccharides delivered via kilomicrons because of saturated fats, and also chronic toll-like receptor 4 signaling. So caused by gluten. Gluten is consumed like from your pizza and other foods, and then that causes lipopolysaccharides, and then the lipopolysaccharides binds to the toll-like receptor 4 on the macrophage, and then that causes inflammation, and that's going to cause semi-maturation of antigen-presenting cells, which means that they're not going to be able to activate T cells properly. Also, lipopolysaccharides can also take up the space on the kilomicrons that was originally supposed to be for fat-soluble vitamins. If LPS is taking up the space on kilomicrons, then the fat-soluble vitamins cannot be delivered. They can't be transported and shuttles. So basically, as a result of the semi-maturation caused by saturated fats, lipopolysaccharides, is that the antigen-presenting cells, they appear activated, but they cannot instruct effective immunity. And that could be dangerous for T cells because the signal is weak and unstable, which is bad because antigen-presenting cells are normally they are normally anti-tumor. Yeah, so antigen-presenting cells are normally anti-tumor, but that's disabled or that becomes impossible if they are semi-mature because of that saturated fats and lipopolysaccharides. So some fruits that might be able to help. There's pears. So pears lower TNF alpha, which is a short for tumor necrosis factor alpha. It also increases epithelial repair. Pears also indirectly improves IL-2 effectiveness, which means that T cells are going to be able to uptake the IL-2. Pears also restore APC and T cell communication. So antigen-presenting cells communicate with T cells, and pears help with that. Another fruit is a banana. It has a short chain of fatty acids, which reduces inflammation, because inflammation is actually can actually get in the way of signaling. So if there's too much inflammation, then the antigen-presenting cells, they can't communicate and send signals to the T cells. The other one is apples. Lowers TNF alpha, allows IL-2 signaling, similar to pears, but slightly less potent. So pears would be better than apples, but apples better than nothing. Okay, and then there's kiwis. Enhances antigen processing, maintains low TNF alpha. As I said before, supports effective IL-2 receptor signaling, so that the T cell can actually absorb the IL-2. Another one is grapes. You have to be careful with the grapes because they can slightly trigger a Treg SKU if overconsumed. So Tregs are like they're basically cells that take up Tregs can actually consume or steal IL-2 away from T cells. So yeah, that and grapes have an influence on Tregs. Next one is papaya, which is one of my favorites. It shifts IL-2 towards regulatory pathways. Excellent for inflammation control. Too much inflammation can block the signals between antigen-presenting cells and T cells, so they can't communicate. Next one is watermelon. Preserves antigen presentation cell metabolic balance. Next is cantaloupe. Cantaloupe, it encourages Treg-compatible IL-2 usage, which means that the Tregs are stealing IL-2 away from T cells, so maybe a cantaloupe might not be a good one. Peaches, mild TNF alpha reduction, stabilizes antigen-presenting cells phenotype. And the last one is pineapples, enhances antigen processing, and also activates antigen-presenting cells, so that antigen-presenting cells can activate T cells. So that's it for the video. Leave your insights down below in the comments. Like and subscribe, and I'll see you in the next video.